Hey guys, welcome to Shekar Tech YouTube channel. So now in this video, we are going to solve problem number 2 in superposition theorem. So in previous class, we have solved the problem when the circuit is having two voltage source. Now what if in the circuit is having current source? So how to solve this superposition theorem? So in this case, okay, the circuit is consisting of one voltage source and current source, and a 5 ohm resistance, 10 ohm resistance, and 3 ohm resistance. So your question is find the current flowing through the 3 ohm resistance by using superposition theorem. So you have to find I I3. So we have to find I3 nothing but current flowing through the 3 ohm resistance by using superposition theorem. Now let us see. Already I explained that how to apply the superposition theorem. So we have a three steps, okay, and let us go one by one, okay. And the step one, what is the superposition theorem? So in linear network consisting of two or more sources, so how many sources are there? Minimum two sources are there, voltage source and current source. Then the response in any element is algebraic sum of responses caused by an individual source acting alone. So the voltage source and current source are connected to this resistance, and you have to find response of individual sources first, okay. So step by step, let us go. The step one, 20-volt source acting. So what does it mean? In step one, 20-volt source acting, then you have to find the response in the element 3 ohm resistance. So it means how much current is flowing from this source 1. So what about the source 2? Source 2 should not be there. That is the definition. When single source acting, so therefore the source should make 0. So when the current source is there here, so how to make? So again same procedure. When the voltage source is there, you must short circuit. When the current source is there, then you must open circuit. Okay. So in step 1, this is the circuit diagram. So 20 volts is acting and the current source should not be there. Therefore, I have open circuited. So this circuit is replaced with this one. Step 1, I current source should not be there. Therefore, I have open circuited. So this is a circuit diagram. So from this circuit diagram, we have to find how much current is coming and how much current is flowing through this 3 ohm resistance. Same procedure. Again, total current. So we have to first find total current. Total current is equal to total voltage by total resistance. Now here this, see, we are coming from like this. This 5 ohms and 3 ohms are connected in series because the current, whatever current is coming from this source, divide here, but here no current will flow because it's open circuit. The current is equal to 0. Whatever the current is coming, that is equal to 0. Let us say I1 coming, I1 will flows only through 5 and 3 because it's open circuited. It's a very important point. When it open circuited, we can also replace circuit like this. So no current, remove this 5 and 3. So 5 and 3 are connected, is only, there is no path here. Therefore, we can consider as single path like this. So 5, 3 are in series. Therefore, total resistance is equal to 5 plus 3 is equal to 8 ohms. Now I1 current is equal to, I1 current nothing but current from this source, current coming from this source. I1 is equal to 20 divided by 8. 20 volts divided by total resistance 8. So 20 nothing but 10 by 4, 2.5 by 2 nothing but 2.5 amperes. Okay, leave it. So this is the current I1. So when voltage source, 20 volt source acting alone. Similarly, you have to repeat the step 2. And now we have to consider only current source acting alone. So 5 amperes acting alone in step 2. So what you have to do when the current source acting alone, what about the voltage source? We must make 0. When voltage source 0, what you have to do then? the voltage must be short circuited. So this is a I have short circuited V1. So this is the Y circuit diagram in step 2. So now we have to find current flowing through this 3 ohm resistance when 5 amperes acting alone. So now these two resistors are connected in parallel because here current is dividing. It's a total current is coming. So we can also replace these two are in parallel like this, and this is the current. So we can also draw like this to better understand for the beginners. And by using current divide rule, we know the total current and we need branch current. So you have to apply current divide rules. So by using CDR current divide rule, I2 current. So I'm assuming this I2 current is flowing from this side when 5 amperes is acting. Therefore, total current is 5 amperes. Then what is the current divide rule? Opposite resistance divided by total resistance. What is the opposite resistance to this? 3 is the 5 is the opposite resistance. Therefore, 5 divided by 5 plus 3. Opposite resistance divided by opposite resistance plus current resistance. Therefore, 5 into 5 divided by 5 plus 3, 8. Therefore, 25 by 8 amperes to I2 current. What is the step 3? So we have to add these two currents. Step 3 is equal to I3 is equal to, so I3 ohms current resistance is equal to I1 plus 8, because both we are adding, because the direction of the V1 current source and both are same direction. Therefore, we are adding I1 plus I2. So therefore, this step 3 is equal to I1 plus I2 5 by 2 by 5 by 2 plus 20 by 25 by 8 is equal to 2.5 plus. So the total current is flowing through 3 ohm resistance is equal to 5.625 amperes. This is the answer. So if the any source is reversed, for example, this the direction is opposite, then we have to subtract. So therefore, that I already told you. So this is a simple equation. So this answer is 5.625 amperes is flowing. So through this 3 ohm resistance. So like that, we have to find the current flowing through 3 ohm resistance by using superposition theorem. Hope you will understand. If anyone has doubt, please write in the comment section. I'll give reply and I'll try to make you understand. And thank you so much.